Alright, so our topic for the study guide is nomenclature, and we're going to be talking about four different nomenclatures. One is ionic compounds, second is covalent compounds, then we're going to look at two different types of acid naming. One will be binary acids, the other is oxyacids, or now that they like to call it, ternary acids. Alright, ionic naming. Now, basically, what the ionic naming is it's a metal plus a non-metal. So when we look at it that way, the metal will come first. You will give the full metal name, and then the second, where the non-metal comes in, you will take the root of the non-metal and add IDE or I at the end. There's no prefixes involved. Okay, so maybe an example would be NaCl, which is sodium chloride instead of sodium chlorine. This is also your everyday table salt. Another example would be magnesium oxide for MgO instead of magnesium oxygen. Alright, so there's another section in ionic naming that deals with the transition metals. Now, this is the part where people get confused because we're going to be looking at metals with different charges depending on the situation. So, to identify this, we'll use Roman numerals. For example, FeO is iron 2 oxide. So you will place the Roman numeral 2 right after iron when you write out the name. Now, bismuth. With bismuth, like some of these have set charges. For example, iron can only be 2 and 3. Bismuth can only be 3 and 5. So, like for bismuth chloride, we'd when the formula is BiCl3, it would be bismuth 3 chloride. But for example, if it was bismuth BiCl5, it would be bismuth 5 chloride. Exceptions to the transition metal rule are between the transition metals are silver, cadmium, and zinc. Now, silver is almost always a positive one charge. So, when in a certain scenario silver is 1, we do not write it. If, for example, it was silver chloride, there where the charge is 1, we would just call it silver chloride instead of silver 1 chloride. Now, in some cases, silver is 2, and that is when we're going to put the Roman numeral for silver. Now, cadmium and zinc have a set charge of 2, so they will never use the Roman numeral method. Alright, so next up is covalent naming. Now, this is naming with two nonmetals, and basic structure of this naming would be in your first nonmetal, you just use the name, unless it's more than 2. Then for the second nonmetal, you follow the same procedure in ionic naming, where we use the root of the element plus the suffix IDE. Now, in covalent naming, the unique thing is the use of prefixes. Now, which I've provided a table on the side. It shows like 1 is mono, 2 is di, 3 is tri, 4 is tetra, so on. So, now, there are some exceptions to using the prefixes. Now, with the prefixes, you're supposed to start using them from di in the first nonmetal name and the second nonmetal name. So it applies to both. I repeat, it applies to both. So that's something very important to remember. And but like the mono is understood in many cases. Now the exception to that is carbon monoxide, which is CO, and that is one of the only cases where you'll see the prefix mono used. Now, the second exception is hydrogen. Now, with hydrogen, whenever hydrogen is used, it will probably be the first nonmetal name position, and it does not require the use of any prefixes. So, there's when stating the full name, you will not use the prefix. Binary acid naming. Now, this is quite simple. It's basically you will take the binary means 2, so you will have two elements. One of them which would be hydrogen, making it an acid. So you will have the prefix hydro then the root of the element, this element will probably be like a halogen, like fluorine or iodine or bromine. Sulfur is also a potential candidate. And after you put the root of the element, you will put ic at the end, followed by acid, of course. So, for example, HF is hydrofluor, as in being the root for fluorine, hydrofluoric acid. And same thing with iodine. HI is hydroiodic acid. Now sulfur, it will be H2S, where it's hydrosulfuric acid. Okay, so second type of acid naming is the oxyacids, or the ternary acid naming. This deals more with the polyatomic ions. We'll be looking at two different types, because most of our polyatomics end with ate or ite, with the exception of ammonium. So, ate, we would take the root of the polyatomic. This time we're not using hydro. I repeat, this time we're not going to use a hydro, and we're just going to take the root of the polyatomic and add ic for polyatomics that end with ate, ate. So, and then this will be followed by acid. So, for example, when we have H2SO4, it will be sulfuric acid. And then same thing with nitrate, it would be HNO3, so it would be nitric acid. So the next step is ite. So ite, you would do the same thing. You would use the root of the polyatomic, but instead of adding ic, we'll use us. So OUS. Now an example of this would be H2SO3, which is sulfite. Hydrogens. So this would be sulfurous acid. Another example with nitrite, it would be HNO2, so it would be nitrous acid. Alright, well, that's all for today with nomenclature.